This graph shows the decrease in price of lithium-ion batteries over the course of 24 years, from 1992 to 2016. And you can see that it goes from $6,035 per kilowatt hour to only $244 per kilowatt hour, which is significant. Lithium-ion batteries are now much more accessible and cheaper than they once were. This technology has transformed energy storage across multiple industries. It allowed for portable electronics, electric vehicles, and renewable energy systems. Massive implications for economic, environmental, and social development, while it continues to evolve rapidly. The first electric cars could not carry passengers, but they were first developed in the early 1800s, at which point they weren't viable due to the limitations of battery technology. The lead acid battery was invented in 1859, but it still didn't result in electric vehicles like we have today due to the lack of energy density. The historical development of the lithium-ion battery took decades. In 1965, NASA developed an early copper fluoride lithium battery, but faced challenges with stability and rechargeability. In 1974, Whittingham created the first rechargeable lithium battery with titanium disulfide, solving ion storage issues, but it was still plagued by fire hazards due to metallic lithium. In 1980, Goodenough replaced titanium disulfide with lithium cobalt oxide, achieving higher voltage and improved air stability, though safety issues still remained. In 1985, Yoshino developed the first commercially viable battery using petroleum coke instead of metallic lithium, solving critical safety problems. In 1990, Don demonstrated graphite anodes with ethylene carbonate, creating higher energy density and completing the modern lithium-ion design. And in 1991, Sony commercialized the first lithium-ion battery, which revolutionized portable electronics with higher energy density. This is a clear comparison between the lithium-ion battery and the lead-acid battery. Lithium-ion can store 5 to 6 times more energy in the same space. There's significantly less wasted energy during charging cycles. 4,000 plus cycles versus lead-acid, which only allows for 500 to 1,000. Lithium-ion batteries can charge faster, and they require zero maintenance. While lead-acid batteries are still cheaper, lithium-ion batteries are becoming significantly more accessible rapidly. And lithium-ion can be partially charged without capacity degradation. The development of the lithium-ion battery has been massive on the level of the diesel engine. It enabled many different applications that were previously not viable. The limits of the battery have not been seen yet, unlike the diesel engine and the steam engine. The battery market is projected to grow significantly over the next several years. It has the potential to reduce reliance on imported fossil fuels, allowing countries to reach energy independence. There are many ethical concerns with how these materials are extracted from the earth. And improper disposal of batteries can be very damaging to the environment. Thankfully, they can be fully recycled, but that requires an investment in infrastructure. And recycling infrastructure is still developing, even in developed nations like the United States. Moving forward, solid-state batteries show significant promise. Vehicle-to-grid technologies allow electric vehicles to serve as distributed energy sources depending on the infrastructure, where they can provide electricity to the grid in the event of an outage. Gigafactories and automation are reducing costs below $100 per kilowatt hour. And overall, this technology has the potential to democratize energy because it becomes significantly cheaper to harness and store your own electricity. So looking back on history, it's become clear that there have been multiple shifts And now we're seeing a transition from internal combustion engines to lithium-ion batteries paired with electric motors. And each one of these transitions has been driven by technological advancement. The most recent one being the discovery of the lithium-ion battery. And understanding these transitions is very important when it comes to understanding where we're headed. This is a clear comparison between the steam engine and the internal combustion engine. There's a very good reason as to why we stopped relying on the steam engine and why we switched to the internal combustion engine. And both of them convert heat energy into mechanical energy. Tesla's revolutionary AC motor allowed for this pairing to become so significant. It relies on a rotating magnetic field to induce current in the rotor. This is what an induction motor looks like. There are many videos and animations online that will show you how they operate. But it relies on the same electromagnetic principles as I discussed in my previous video. And Tesla's AC motor is simple, reliable, and it has the ability to regulate speed and torque with precision. It paved the way for widespread industrial applications. These motors are used in many things. Electric motors achieve significantly higher efficiency at about 85 to 90%. They have zero direct emissions during operation. And they have fewer moving parts overall, less friction, no need for oil changes. And electric motors deliver immediate power. And regenerative braking systems recapture energy. So to draw the clear parallel, just as internal combustion engines improved efficiency over steam engines, electrical systems significantly outperform internal combustion engines. And new technologies initially cost more, but over time, they become more economical as production scales, which is what we're currently seeing right now with the lithium-ion battery. These gains in efficiency and the heightened level of automation that we're seeing in our society is having profound impacts much faster than we could have imagined. These systems become more efficient with more capability and the ability to automate things that we otherwise thought would not be automated. And moving forward, this has significant societal economic impacts. We're seeing a great centralization of power due to this increase in efficiency. These technologies have the capability to be much more sustainable, a cyclical nature in which they can be infinitely recycled, harnessing renewable energies. And moving forward, I'm going to cover the General Motors EV1 and the AC Propulsion T0, which are two fascinating vehicles as to the electric revolution in terms of automobiles, which happened in the 1990s. So stay tuned. If you've been enjoying my videos, please consider liking and subscribing, and I'll see you in the next one. Thank you. And Otto thanks you as well.